All right, so we are going to go ahead and we're going to get started. So today we are talking about multiplying a matrix by a scale. So up until now, we talked about, on Monday, we talked about what matrices were, and they're a rectangular array used to organize data, and we talked about how to find their dimensions. On Tuesday, we talked about how to actually take that information and turn it into a matrix. And then yesterday, we talked about adding and subtracting matrices. Today, we're going to talk about multiplying a matrix by a scalar. So let's go ahead and let's look at that. So scalar multiplication, when we have a matrix, so let's say this matrix A here, we have, so let's say we wanted to find 2 times matrix A. So we're going to multiply the entire matrix by the scalar of 2. 2 is our scalar. We would distribute the 2 into the entire matrix. And I wish that, okay, cool, so that we can see it. So if you look, it shows you that we're going to multiply the 2 times the -4 and leave the answer where it was. We're going to multiply the 2 times the 0 and leave the answer where that 0 was. You're going to multiply the 2 times the 3, and you're going to leave the answer where that 3 was. And you're going to multiply the 2 times the 6 and leave the answer where the 6 was. So when we go about solving it, and let me pick a different color in case we can't see the green on that purple. So our 2 times our -4, we have a positive and a negative. So it's going to be, our answer is going to be negative, and 2 times 4 is 8. So we're left with -8. Because the -4 was in our first row, first column, that -8 answer is going to stay in the first row, first column. So then we have 2 times 0, and that 0 is in our first row, second column. Well, anything times 0 is 0. So our answer is going to stay in that first row, second column. So then we have 2 times 3. 3 is in our second row, first column, where our answer, 2 times 3 is going to be 6, is going to stay right there where it's at. And then our 2 times our 6. So our 6 is in our second row, second column. So 2 times 6 is 12. And our answer would stay in that second row, second column. So you're multiplying your scalar by, you're distributing it throughout the entire matrix. So you would multiply it by everything in there. And your answers are going to stay where the original number you're multiplying the scalar by was. So let's look at a couple more examples. And remember, so because we're multiplying it by what's already there and leaving the answer there, our answers will always have the same dimensions as when we started. All right, so let's go look at some more examples. So if we look at, let me move this 3. If we look at 1, it says 2 times matrix A. So matrix A says that I have 5, 8, 0, 4, 2, and 5. And I'm going to leave it, I'm going to rewrite it so that we can see our steps on another one. So what I'm going to do is multiply. What this tells me is that I'm multiplying 2 by everything in matrix A. So 5 times our 2 in our first row, first column, 8 times the 2 in our first row, second column, 0 times the 2 in our second row, first column, 4 times the 2 in our second row, second column, 2 times the 2 in our third row, first column, and then our 2 times the 5 in that third row, second column. So then all we would need to do is multiply it out and leave it where it was. So 5 times 2 gives us 10, stays in our first row, first column. 8 times 2 gives us 16, staying in that first row, second column. 0 times 2 gives us 0, and our answer is going to stay in that second row, first column. 4 times 2 is going to give us 8. We're going to leave that in our second row, second column. And then we're going to multiply our 2 times our 2 is 4, and we're going to leave the answer in that third row, first column. And then 2 times 5 give us 10, and we're going to leave that answer in our third row, second column. So then, if we look, our answer matrix has the same dimensions. I have 1, 2, 3 rows by 1, 2 columns. So yeah, ended with a 3 by 2, and we started with a 1, 2, 3 by 1, 2. So we started and ended with a 3 by 2. All we did was take every single number in that original matrix, and we multiplied it by that scalar of 2. So I'm going to leave that for a second so that you can go ahead now and pause it if you need to fill out anything, so that now I'm going to erase it and move on to that second one. So my second one, I have a matrix. This matrix is 1, 2 rows by 1, 2 columns. So I have a 2 by 2 in matrix B. So when I have my answer, my new matrix should also be a 2 by 2. So I'm going to take that 3 and I'm going to multiply it by everything in matrix B. I'm going to write it out so you can see the steps when you are doing it. As soon as you recognize that it is 3 times each individual piece, you do not have to write out this multiplication matrix like I am doing. So we have our 3 times that 10 in the first row, first column. We have the 3 times the 9 in the first row, second column. We have the 3 times the 0 in the second row, first column. And we have the 3 times the 3 in the second row, second column. So now all I should have to do is multiply it out. And this is the step. Once you recognize that you're just multiplying it, if you just want to give me the answer set because you can do the multiplication in your head, that is perfectly okay. But I'm going to show you right now so we can see the steps. So then I know my 3 times my 10 is 30. So we're going to leave it in that first row, first column. My 3 times my 9 is 27, and we're going to leave that in our first row, second column. We are going to say 3 times 0 is 0, and we're going to leave that in our second row, first column. And we're going to say 3 times 3 is 9, and we are going to leave that where the original 3 was in that second row, second column. So this right here is our answer matrix. And if we look, we started with a 2 by 2, and we ended with a 1, 2 by 1, 2. We ended with that 2 by 2. All right, I'm going to give you a second to pause that and fill out any other notes if you were trying to fill that out. And then I'm going to go ahead. I'm going to erase it because I'm sure now by this time you paused it and you've copied down what you needed to copy down. All right, so I'm going to look at this next example. We are multiplying C by a scalar of 1/2. So I have my matrix C is this one where I have 6, 2, 28, and 16. So I'm going to multiply everything in there by our scalar of 1/2. So I know that I'm finding half of these numbers. So 1/2 times 6. So half of 6 is 3. Half of 2, so half times 2, so half of 2 is 1, and we're keeping them in the same place. The 6 times the half stayed in that first row, first column. The 6 times 2, the half times 2 stayed in our first row, second column, and half of 2 was the 1. And then we're going to say half times the 28. So we're in that second row, first column. Half of 28 is going to be 14, and we're going to leave it in that same spot. And then we have half of 16. So half times 16 is 8, and that's in that second row, second column. And we are going to leave it in the same spot. All right. And I'm going to do one more example problem. So then I have 6 times D. So we have D, and we're going to multiply it by a scalar of 6. So let's go ahead. We're going to copy that. Move it up here so we can do it. So let's delete the 3. Delete 3. And we're going to paste, and we're going to work on 4. So we have matrix D. And we want to multiply it by a scalar of 6. So I'm going to take my 7 in my first row, first column, and I'm going to multiply it by 6, and 6 times 7 is 42. So my answer is going to stay in that first row, first column. I'm going to take my 6 and I'm going to multiply it by my 4, which is in that first row, second column. So 6 times 4 is going to give me 24. And my answer is going to stay in that first row, second column. I am going to take my 6 and I'm going to multiply it by the 2. And I know 6 times 2 is 12, and that answer is going to stay in that first row, third column. I'm going to do the same thing for my second row. So I have 6 times 1. Second row, first column is 6, and my answer is going to stay in that same spot. And again, let me pick a different color. 6 times that 8. 6 times 8 is 48, and we're going to leave it in that same spot, that second row, second column. And then let's pick, what color have we not used? Let's use a color we haven't used already. Let me pick a different color, please. How about red? No, we use red. Gray. We'll use gray. So we have 6 times that 4. 6 times 4 again is 24. We're going to leave the answer in that same spot that 4 was in our second row, third column. And if we count 1, 2 rows, 1, 2, 3 columns, we started off with a 2 by 3. And we ended with a 1, 2 by 1, 2, 3. We ended with a 2 by 3. All right, so our objective for the day was to be able to multiply a matrix by a scalar. We realized that when we are multiplying a matrix by a scalar is the same as distributing that scalar throughout the entire matrix. You're multiplying each individual piece of the matrix by that scalar. The dimensions we start with are the same dimensions that we end with, because when we multiply each portion by that scalar, the answer is going to stay in the same spot. All right, so if you have any other issues or questions, please come to our small group today. Otherwise, go ahead, you can go ahead and get started on that work on Schoology. All right, guys, have a great day. And if I don't hear from you tomorrow, have a fantastic weekend.